Hi, I'm Chris, and in this video we're going to take a look at how to use completing the square to solve a question on conic sections. So when you're dealing with conic sections, that means we're talking about parabolas, ellipses, hyperbolas, and circles. And in this case, sometimes you'll be given the standard form, but in this case we're just given this form of an equation for a hyperbola. And the reason we know it's a hyperbola is because we have an x squared term, we have a y squared term, and we have a minus in between them. So this minus here is the most important indicator letting us know we're dealing with a hyperbola. But this method that we use here is going to be something that you'll see applied in both circle and ellipse questions as well. So for this hyperbola question, the first thing that we want to do is we want to get whatever the constant is over to the other side, because to complete the square we want to have the number separate from any of our variable expressions. So let's write that out. First step. So we're going to just move the 59 to the other side. So we now have 4x squared minus 8x minus 3y squared plus 18y equals 59. Second step. For a hyperbola, we know that our standard form is going to have an x minus h quantity squared and a y minus k quantity squared piece to the expression, which means we can't have coefficients on the x squared or y squared terms, and we're going to want to factor those out. Now when you write this, what I recommend doing is I recommend leaving a little space so that you can complete the square. Some students write it in as they go, but here we're going to just leave a little space and then we'll fill it in afterwards to make sure we understand that part of the process. So for now, for the x squared term, I have a 4 in front, so I want to factor out a 4 so that I'm left with just the x squared. And when I factor out a 4, if I divide negative 8 by 4, I get negative 2. And then that's where I'm going to leave my little space to complete the square. I'll worry about that part afterwards. And here, for the y expression, so I'm factoring out this value of negative 3. So I'm going to have y squared. And when you divide 18 by negative 3, you're going to have a minus 6. And again, a little space equals 59. I'm going to grab a different color here. And to complete the square, whatever this value is for your second term, in this case the negative 2, you're going to take half of that and square it. You might have learned in class that it's b over 2 squared, and that's exactly what we're doing for a polynomial in the form of ax squared plus bx plus c. You're going to take b, divide by 2, and then square it. So negative 2 divided by 2 is negative 1. When you square it, you get a plus 1. Now here's the key. Whatever you add to this left side of the equation, you also have to add to the right, but you want to be very careful because the coefficient that you have in front of your parentheses does matter. So even though I'm only adding a plus 1 inside the parentheses, that plus 1 is really being multiplied times 4. So that means to the other side over here, I have to add a plus 4. And then for this one, negative 6 divided by 2 is negative 3 squared is going to be a plus 9. So I'm adding plus 9 inside this parentheses, but it's being multiplied times a negative 3. So on the right side of my equation, I'm really subtracting 27 because this is equivalent to saying that I'm subtracting 27 here on this left side of the equation as well. And I would say for most students, when first incorporating completing the square to these kinds of questions, that's the step most commonly forgotten. So just be very, very careful not to forget that you have to distribute that coefficient to each constant when you're deciding what needs to be added to the other side of your equation. Now we can write this out in factored form, and so this will end up being 4 times the quantity x minus 1 when you factor it squared. So we're just factoring out x minus 2x plus 1, and that is going to be x minus 1 times x minus 1, which is x minus 1 quantity squared. And then here, minus 3 times. So when we factor this out, this will factor into y minus 3 times y minus 3, which is y minus 3 quantity squared. And if you notice for each one, what you factor it into, whether it's x minus 1 or y minus 3, this number is just half of this. So you can find that value relatively quickly. And that's really the whole point of completing the square, so that we get these squared values for the x and the y terms. And then on the other side, I have 59 plus 4, which is 63, minus 27, which will give us 36. Now for our last step, if we remember, standard form of a hyperbola requires us to set it equal to 1. So to get this equal to 1, it means I have to divide everything by 36. Everything by 36. And after doing that, when we simplify or reduce each, we'll be left with x minus 1 squared over 9 minus y minus 3, that quantity squared, over 12 equals 1. And this will be our standard form of this hyperbola. From there, you'll probably have a number of questions that you're asked to answer. The hard part's getting it in standard form. From there, you can figure out the center, the value of A, the value of B, the value of C, where each one of your asymptotes would be, etc. So those questions will follow on more complex examples, but for right now, we just want to make sure that we understand this process of arriving at our standard form expression for the equation of a hyperbola from this. So if we can get from here to here using completing the square, then we're in good shape. For more, please feel free to watch our other videos, and thanks for watching.